All right, these are some homework questions from the Chapter 4 review section that starts on page 318. And we're going to look at number 83 first. And it's a derivative question that asks you guys to find the equation of the tangent line. So when I look at this problem, the first thing I do is I always change the radical into a fraction exponent. And we have an x minus 2 squared. We're actually going to incorporate that in. I'll show you it in two steps here. Step 1 would be to take the x minus 2 squared and then change that cube root to a 1/3 power. But then step 2, when you raise a power to a power like this, you multiply the exponents. And 2 times 1/3 is 2/3. So what you just actually have is x minus 2 to the 2/3 power. And if you want to do it in one step, the shortcut for this, when you're converting something like this into a fraction exponent, this one becomes the numerator, and this one becomes the denominator, and you just end up with the 2/3 power. But once you've done that, it's a much easier derivative to take. So now let's do that. It's going to be power rule first. So when I go to take y prime, I'll leave the x minus 2. I will multiply by 2/3, subtract 1 from the exponent. 2/3 minus 1 ends up being negative 1/3. And then technically we should do the chain rule here, but the derivative of x minus 2 is just 1. So really our derivative just ends up being 2/3 times x minus 2 to the negative 1/3. Okay, now to find the slope, we're going to take our x value, which is 3, and we're going to plug it in. So the slope would be 2/3 times 3 minus 2 to the negative 1/3. And that works out nicely because 3 minus 2 is 1. And 1 to any power, oops, that's a third, not that it matters. 1 to any power is 1. So basically the slope ends up being 2/3. So if the slope is 2/3, the point that was given in the question is our x1, y1. Our final answer would be y minus 1 equals 2/3 times x minus 3. And you could leave it like that. That's fine for an answer. Or let's say this was on our test and it was a multiple choice question and maybe the answers were in slope-intercept form. All you would have to do is distribute the 2/3. That would give me 2/3 x minus 2, and then just add 1 to both sides. And that would be 2/3 x minus 1. So both of those answers are fine, the black and the purple. But like I said, if this was a multiple choice question, you're probably only going to see the purple choice there. All right. The second homework question that was asked was number 91, and the equation, it's implicit differentiation, and it asks you guys to find the equation of the tangent line again. It also asks you to find the equation of the normal line, and I'm going to have you skip that. I didn't do normal lines. You'll do them next year in AP Calculus. So let's just do the tangent line, but we're doing it implicitly. So when I take the derivative implicitly, the derivative of x squared is 2x, but then you get a dx dt. Oh, no, start over. I was thinking related rates. The derivative of 2x, we're taking the derivative with respect to x. So the derivative of x squared is just 2x, and that's it. Now the derivative of y, that's 2y with a dy dx on it, because we are taking the derivative with respect to x here, not t. Now the derivative of 10 is 0. Any constant is always a 0. So basically, I would, if I want to solve for dy dx, I would subtract 2x from both sides. And we get 2y dy dx equals negative 2x. Divide by 2y. And dy dx ends up being, you can cancel those 2's, it's basically just negative x over y. Now for the tangent line, The slope we're going to get from plugging both x and y. And that's the difference between these two questions. On explicit or normal differentiation, you only have to plug x in. This one I have to plug in both x and y. So what I get is -3/1, or -3. And then we'll finish the question exactly like our last one. We'll do y minus 1 equals the slope, -3, times x minus x1, which is 3. And I'll do the same thing I did last time. That's fine for an answer, or if this happens to be a multiple choice question, distribute the -3. You would have -3x plus 9, add 1 to both sides, and y equals -3x plus 10. So yeah, same as the last one. Either answer is fine, black or blue, but if this happened to be a multiple choice question, you're probably going to see the blue choice there. And again, don't worry about the normal line. I know the directions ask you to find the equation of the normal line, which might have been confusing for you. I didn't go over that with you. You'll see that next year. All right, we had one more question that was asked. It was number 97. It's about, I already drew the picture for it, but basically it's about, it says two cars start in the same place. Car number 1 is driving west, and what I did is I labeled the start right here. This purple point, we'll make it purple. That purple point is where it started. And it says car 1 is driving west, which would be to the left, 65 miles per hour. Car Y is driving north, which would be up, 50 miles per hour. So I drew the X and the Y, and I drew the little arrow to show that they're moving. Those things are increasing. And the speed of the car is the rate. You know, dx dt is how fast X is increasing, 65 miles for every hour. And dy dt, same thing. It's how fast y is increasing. Now, what the question said is, how fast is the distance between the two cars changing? So I added that third line, z, and I said, let's find dz dt, and then it said after a half an hour. So basically when t equals 1/2. So this is one where all three of those are changing. Nothing's constant. We did a Pythagorean theorem. That's what this is going to be, because this is a right angle here. We did a Pythagorean theorem question earlier where the hypotenuse was constant, so we just put a number in for it. But as those cars are moving, z is changing also, so you can't have a constant there. Now, our equation, our relationship, is going to be the Pythagorean theorem, as I mentioned a second ago. It's going to be x squared plus y squared equals z squared. And we can take the derivative. Now this time it is with respect to t. This is what I started to do on the last question. So the derivative of x squared is 2x, and you get a dx dt. The derivative of y squared is 2y, and you get a dy dt. And the derivative of z squared is 2z, and you get a dz dt. Now what you can do if you want, and you don't have to, the question will work out even if you don't, but I notice if I divide everything by 2, I can basically just knock these 2's off there. So let's just forget about those. If you leave them in, you'll still get the right answer. It's just one extra number to work with. So let's start plugging in. Let's see what we have and what we're missing. We don't have a value for x, but dx dt is 65. We don't have a value for y, but dy dt is 50. We don't have a value for z, and dz dt is what we're trying to find. So basically what we need to do is figure out what x, y, and z are. Now the important piece of information here is the question said after a half an hour. So after a half an hour, you can figure out how far these cars have gone by basically just dividing that number by 2. For example, to find y, if the y car is going 50 miles per hour, then after a half an hour, it's gone 25 miles. And same thing with x. The x car, if it's gone for a half an hour, is half of 65, which would be what, 32.5? Now the z one is the one that's going to take a little work. because we don't know, we don't have a number we can just divide by 2. So what we need to do, and I showed you guys this on a question, is we need to draw like what I call the snapshot picture. So in the blue triangle right there, x, y, and z are changing. But I'm going to draw a green triangle here. And this is when t equals 1/2. So when t equals 1/2, we already figured out that y is 25 miles and x is 32.5 miles. What we can do is Pythagorean theorem to find out what goes here, and then whatever that number is fills in our last blank. So let's do that. We have 25 squared plus 32.5 squared equals, we'll call it z squared. That's basically z right there. Let's use a calculator for this. So basically z squared is 1,681.25. And if we square root that, it's very close to 41. I'm going to call it 41. It's actually 41.003. That's close enough that I'm just going to put a 41 right there. So that was the question within the question. You know, that what I did in green right there was the extra work that you needed to find the one missing piece from our derivative equation. Now what we want to do is finish solving for dz dt. So I'm going to use my calculator again. And we'll go 32.5 times 65 plus 25 times 50. We end up with 3,362.5 equals 41 dz dt. Divide both sides by 41, and that's going to get you the final answer to the question. So dz dt ends up being, it's pretty close to 82. I got 82.01, so I'll call it 82. And that would also be in miles per hour, because that's a linear distance again, so it's the same units that dx dt and dy dt were in. And here's another look at the whole question from beginning to end. All right, I hope this helped you guys, and do some studying and be ready for a test, and I will see you guys on Friday.